Hello, Workplace Math 10 students. Just wanted to go over a video of the Chapter 6 review assignment, just so everyone is clear. I'm going to walk you through each of the 10 questions. So I'm just going to share my screen with you. So once again, you should have been working on your Chapter 6 test review assignment yourself. I would like you to try and do this yourself independently first, see whether you can do these 10 questions yourself, and then if you are struggling at all, this video is here to guide you as to how to do each of these questions. So let's take a look. We're starting with question 1, how we would work through this. So question 1 says the shape ABCD is an artistic bookend with a similar partner bookend shaped RSTU, which is slightly larger. Which side in RSTU corresponds to side CD? So because these are both similar figures, what we know is that when similar figures are indicated, the order is very important. So what we see here is that CD is listed as the third and fourth angles in this shape, and therefore the corresponding angles or side length in this case to this is TU, which is the third and fourth. So the answer to this question is TU. For question 2, it says Bob was asked to scale a square of quilt fabric with a side length of 20 centimeters using a scale factor of 35%. What is the new side length? So the original is 20 centimeters, and then we are going to multiply that by the scale factor of 35%. Now, reminder that 35% is as a decimal equivalent 0.35. We know this by taking 35 divided by the 100% to make 0.35. So when we multiply 20 by 0.35, we arrive at the answer of 7 centimeters. Looking at question 3, what we see here is we see that there are two different shapes here, and they're asking here which of these statements below, used alone, will help us to determine that these are not similar figures. So the first one, side EF is twice the size of AB. Well, that is not going to, in and itself, prove that these are not similar figures, because just because two figures are different sizes does not mean that they can't be similar, because they can be different, just proportional. B, where it says side AD is the same length as EH, but once again, this alone does not disqualify these two shapes from being similar, because even though these two sides may be the same length, they may be correspondingly different sides. So AD does not correspond to EH potentially, and so therefore it could even be similar as well, because these two similar figures could be exactly the same size potentially. Now we look at D as well, and I'm just going to skip over C here, but we look at D, it says angle E is the same measure as angle F. Well, once again, in this case, this doesn't disqualify from being a similar figure. In fact, it supports, it's giving evidence that it is, because it's saying that angle E, which corresponds with angle F, in the same shape, are just the same. Well, that doesn't really help us at all to determine whether this corresponds with this shape. Now, the one, though, that is the correct answer and does definitely disqualify these two shapes from being similar is where it says that angle D, which corresponds with angle H over here, are in fact two different angles. So this one's 113 degrees, this one's 120 degrees. Because these are corresponding angles, one of the definitions for similar figures is that these two angles, corresponding angles, must be equivalent. So therefore, if this statement is to be true, which it is in this example, then that means that these two shapes are not similar. So question 4 says two of the angles in a triangle have a measure of 69 and 51 degrees. Which of the angle measures below could belong to a triangle that is similar to this triangle? So the reality is that the triangle always has three angles that collectively add up to 180 degrees. So we know two of the three angles, that's 69 and 51 degrees, and that when we add them up, adds up to 120 degrees. If we know that all three angles will add up to 180, well then the leftover angle must be the difference between 180 and the two angles we have, which is 120. So therefore the remaining angle is 60 degrees. And when we look at this, therefore, then we know that the three angles must be the two that were given to us, 69 and 51, plus the third one we just calculated. And so the only correct answer here is C here, because basically 69 and 60 are in fact two of the angles, so therefore C is correct. Question 5 looks at this. It says, John drew the two similar right triangles below when he was trying to figure out the materials he would need to repair a corner of a wooden frame. What scale factor do you use on ABC to create the smaller right triangle DEF? What we see here is that CB, side length CB, and side length FE correspond with each other. And what we also hopefully remember is that the scale, the model, scale is equal to the model over the original. So if this is the model over here, we need to look at the length of that model length, which is 3 centimeters, and we need to put that over the original length, which was 15 centimeters. And when we look at that, 3 over 15, we can simplify that as 1/5, which would be the correct answer to state here for our scale. Question 6 reads, the figure MNOP is similar to ABCD and was created using a scale factor of 1/6. So it says, what is the measure of each angle? So once again, regardless of what the scale factor is, if these two shapes are similar, then the definition of similar figures is that the corresponding angles will be the same. So if I look at angle M here, angle M corresponds, hopefully you can see, angle M corresponds with angle A over here. So therefore, the angle measurement must be 110 degrees for angle M as well. Likewise, angle N corresponds with the angle over here, which is angle B of 50 degrees. So therefore, angle N is going to be 50 degrees. Now, those hopefully make sense. Those are pretty easy to understand. But let's now take a look at the next two parts of this question. So if we look here, it says, what is the measure of each side, MN and NO? So if we look again at these shapes here, we see that side MN is right here. And so we see that MN is right here, and this corresponds with this side length over here. Now what we have to consider is that this is 1/6 the size of this. So that's why we're going to multiply by 1/6, or in essence divide. Multiplying by 1/6 is the same as dividing by 6. And so the length of that side is going to be 5.83. So basically what we're saying is that this is going to be 5.83. And then likewise, same idea here. We're looking at NO now, so that's this here. And this corresponds with this length here, which is 20. So once again, we're going to take 20 and divide by 6, which is going to come up with the answer of 3.33 centimeters for this. So hopefully that makes sense. I'm just going to clear this off so this you can get that out of the way. But basically that one should hopefully kind of walk you through that question. Now the next question here, question 7 says, Jill drew the figure below to show where a shadow should fall in a diorama, where a tree is parallel to the side of the building. Find the missing length X. So basically what we see here is we see that this is X here that we're looking for. And in essence, what we have here is we have two different types of triangles that are being created here. So essentially we have the shorter triangle, which I'll just sort of draw in here, smaller triangle, and then we have, and I'm going to just make it a little bigger so it's obvious, that this is the longer triangle that we have here. And so what we end up here is that we have the shorter triangle, which has side lengths of 20 and 15, and then we have here collectively the 10 and the 15 really makes a side length for this of 25 centimeters. And now what we're trying to figure out is we're trying to figure out what 20 plus this X is going to be. So what is this part here that collectively would add up to this? So basically, if we look at this, we can see that what we have is that the 25 here is the corresponding side length to 15. So that's why I wrote this as 15 over 25. And then likewise, the the other part of this smaller triangle is 20 here. So we have this 20 up here. And then what I have here is the collectively, I'm trying to figure out what T is, which is the whole length all the way from here to here. And so to find this, I would multiply 25 by 20, which is going to give me the 500. And then I'm going to divide it by 15. So I'm going to divide this by 15. Obviously, I would divide both sides by that to find out what T is. And when I plug that in my calculator, 500 divided by 15, I end up with 33.33. Now, that is the length of this T. It's 33.33. But really, this is comprised of the 20 centimeters we already have. So therefore, I have to subtract off the 20 centimeters. And so what is left, the X part here, is just this 13.33. Hopefully that makes sense to you. So I'm just going to erase that off here, and then we'll go on to the next question. So let's looking at question 8 now. It says, Bob drew the two triangles below his sketches for seasonal cookies in his bakery. Are the two triangle scales copies of each other? Calculate the scale factor for each side to explain your answer. So what we need to do first is that we're not really told the angles here, so we don't really know for sure what are the corresponding sides, unless if we're going to make the assumption that they are similar, well, then the longest sides have to match up with one another. So basically, if the longer sides, and if we look at it here, the longest side here that we have is 210, and the longest side here is 60. So that's why we're going to match these up, and I'm just going to write this up and see what the scale factor is. So if I look at this, the scale factor of these sides are 3.5. Now, if I look at the smallest side, so the smallest length on both of these is 140, and in this case, 40. So if I write that 140 and 40, then, oh, that one has a scale factor of 3.5 as well. But the leftover ones, 160 and 50, if I put those here and calculate, so 160 divided by 50, that's a scale factor of 3.2. Well, these don't match then. So therefore, then this is not similar, because in order for it to be similar, all three side lengths have to have the same scale factor. So this is not a similar figure. So I'm just going to erase these off here again and move down to the next question. So question 9, it says the two figures below are similar figures. If the second figure was created with a scale factor of 1.75, label the angles and determine the lengths of the sides. So basically what we're saying here is that these are the similar figures, and therefore, if these are similar, then they must share the exact same angles. So that is why this angle here, that is why this angle is going to be the same over here, because it corresponds with one another. And likewise, we see here, this corresponds with one another, so this would be the exact same angle, and so forth for the other two. Now, the tricky part is, how much bigger is this going to be? Well, it says scale factor of 1.75. So in essence, what this is going to be is 18 times 1.75. And what we do when we plug that into the calculator is find out that that adds up to 31.5. So we're going to do the same thing for each of the unique side lengths. So obviously we have 25 twice, so that would be the exact same for both of these, and then 12 times 1.75, which would be the 21 down here. So once again, and when we do that, we can easily label and figure out missing side lengths. So hopefully that makes sense to everyone. And looking at the last question then, it says a 10-meter tree casts a shadow that is 18.5 meters long. How long would the shadow be for a man that is 1.7 meters tall? So I put a hint here that might be helpful to draw a diagram to help you understand this. So let's take a look at how this works. So basically, we have here, we have an example of a tree, and I could draw a really horrible tree here. But this is basically 10 meters long here, and it's going to cast a shadow that is 18.5 meters long. Now, likewise, if you have a man who is standing here, so I'll just draw a really bad looking man here, stick figure man, is 1.7 meters, then it's asking, what is this? What is this length here? Well, this is what we don't know. Okay, so what we see is that side 10 and 1.7 correspond with each other. That's why we wrote this fraction this way. And then what we see is 18.5 and x should correspond with each other. And because the x and the 1.7 are together, then we have to have these on the same line here. So remember here now that if we have this, I'm just going to erase that out. So if we have this, we need to cross multiply here. So basically what we should be doing here is when we're cross multiplying is we're going to multiply 1.7 by 18.5, which when we plug into our calculator is 31.45. And then we're going to divide by the leftover value of 10. So I'm going to divide both sides by 10 here. And so what we end up with is we go 31.45 divided by 10, which is going to be 3.145. So this man's shadow is going to be bigger than what he is. It's going to be 3.145 meters long. Hopefully that makes sense. So that summarizes all of what we've looked at. So hopefully that answers all your questions. I strongly encourage you to go through this video, and anything that you did not understand, please make sure you make corrections to it, because when you do your test, you are going to want to be able to refer to your worksheet, which you can definitely use to write your test next Tuesday, April 14th. So that's it for the video. Hopefully that made sense and you are able to